So in this problem, we're looking at two possible events that can happen. Person T equals gets a ticket, or event A equals gets into an accident. Okay, so we want to know if if these two probabilities are independent. So what we know that there's an 18% chance that a teenager gets into a car accident. So the probability of a car accident is equal to 0.18. Over that same period of time, there's a 34% chance of getting a ticket, and the probability of getting into a car accident and getting a traffic ticket. So we aren't necessarily saying these are happening at the same time, that the person gets into an accident and gets a ticket because of it. We're just saying that the probability that a 16 to 19-year-old has an accident at some point in those years and also gets into a traffic accident at some point. They could coincide, they may not. So there's a 10% chance of that. Well, in order for these to be independent, if these are truly independent, then the probability of A and T should equal probability of A times the probability of T, if independent. That's a big if. If we find this product, 0.18 times 0.34, we get 0.0612. Well, 0.0612 is not the same thing as 10%. In fact, what this is saying is that if they were independent, that there would only be a 6.12% chance they'd get both a ticket and into an accident. But we're saying the probability that both of these events occur is actually 10%. So these are not independent because of that reason. Their independent probabilities do not give us the probability of both. Okay, so we want to know the probability that, given that a teenager gets into an accident, what is the probability that he gets a traffic ticket? Okay, well, we know that the probability of A and T can be given to us by taking the probability of A, the probability of getting into an accident, multiply that by the probability of getting a traffic ticket given that you've gotten into an accident. Okay, well, so in this case we are saying that getting a ticket is probably a little bit more likely if you get into an accident. Well, let's fill in what we know. So we know that this is 10%, and we also know that A is 0.18. We don't know what the probability of T given A is, but we can find it pretty quickly by just doing some division. So divide by 0.18. And this is a very, very common formula. So this is something that we want to really keep in the back of our minds as we use this. Remember, this is a derivation of an earlier formula. 0.1 divided by 0.18. So we get about 0.56. So about 0.56. Okay, so there's about a 56% chance that you get a ticket given that you've been in an accident. So maybe that the teenager is causing that accident. Who knows? Why did the probability change in this way as compared to the unconditional probability of getting a traffic ticket? So remember, probability of a traffic ticket is 34%. But given that you've been in an accident, the probability of getting a ticket goes up a little bit. Maybe you're at fault. So I'll leave that blank. I'll let you fill that in. But it's because, we probably think the events are dependent on one another. Given that a teenager gets a traffic ticket, so given that they get a traffic ticket, what is the probability that he gets into an accident? Wow, okay, so we don't really have information on that entirely, but we can build ourselves a little table. So either the person gets into an accident or doesn't get into an accident, gets a ticket, doesn't get a ticket. Well, we know that this is equal to the probability of A and T divided by the probability of T. We already know that the probability of A and T is 0.1. We know that the probability of getting a traffic ticket is 0.34. So actually, excuse me here, we don't really need the table because we already know these two values. And 0.1 divided by 0.34 gives us about 29%. Okay, well this means that given that you've gotten a ticket, the likelihood that you also get into an accident is 20%.